in our team, we want to have a global perspective. And for this reason, we are analyzing a quite large-scale dataset. We are talking about 1.5 million of international flight connections between cities worldwide. So you can see, for instance, in the map, you can see in purple, like some nodes connected, some airports connected to Singapore and Singapore as well. And we want to address the question, so what is the position of Singapore in this global air traffic network? How connected is Singapore to all the other cities worldwide, and how central is its position? In network science, there are actually different ways to measure the centrality of a node in a given network. You may have heard about degree centrality, which is basically just the number of connections that a node has with all the other nodes in the network. If you think about your social connection on Facebook, basically this is just the count of your friends on Facebook. And this is a simple measure, but there are also other more advanced measures. For instance, there is this eigenvector centrality, which measures how well connected a node is with other hubs or other very important nodes in the network. And what we see is actually that Singapore is very high in eigenvector centrality, and this measure kept increase over the years. This is quite a surprising finding, as we did see some major change over the years in this air traffic connection. We did see new hubs coming out. For instance, there was Doha, Dubai Airport, which really jumped up in the ranking, just talking about degree centrality. But actually, Singapore managed to to be high in its central position for this eigenvector centrality. So our driven research question is how can we leverage this central position of Singapore in this air traffic network to further boost Singapore's economic growth and development. To study economic growth, actually, we look at multinational companies. Also here, we have been analyzing a large-scale dataset. It's called Orbis. And in total, we do have information about 400 million companies. We have information about revenues, geolocation, industrial classification. More importantly, we do have information about the location of the headquarters of the company and all its subsidiaries. So guess what? We built out another network, which is still we have nodes in this network where our cities. Links now are business relations between subsidiaries and headquarters of the same multinational company. So our question is, can we predict this structure, the structure that we see here, this business structure, given the information on the global mobility flow in the air traffic network? It's something that we would like to address, and we don't know yet the answer, but so far, our empirical evidence showed that it may be possible, as we do find already some correlation between mobility and economic outcome. We do measure mobility in number of direct flights and economic outcome in number of companies in a given cities. We did this analysis both on a city level and on a country level. And what we also want to look at is whether these findings are actually stronger for specific industry, specifically for knowledge-based industry. I'm talking about what we can also call high-skill company, so management companies, tech companies, professionals. And for at the country level, actually, we do find a stronger effect in this industry. As I mentioned, this is actually a first step, first insight for a longer project. Our goal is to develop a network-based and AI framework to predict location choice of multinational companies given the air traffic connection, given the framework, we may be able to identify optimal and critical pathways. And also, finally, we want to connect back to the local mobility. So we want to have like a unique framework to have like global mobility and local mobility to improve, enhance like efficiency and robustness of the transportation system here in Singapore. Thank you. And now it's Alok's time.